everyone. Let me just get the PowerPoint loaded. Okay, amazing. All right, hi, I'm Sriya Potham. I am a field CTO at Wiz, and today I'll be talking about how cloud security has evolved, the challenges that CISOs face in managing security across fragmented tools and teams, and how we can transition security models from what we've had in the past to a unified, contextual, and automated approach. At Wiz, really quickly, to introduce myself, my focus is helping organizations operationalize and security at scale, ensuring that security is embedded, automated, and actionable throughout the cloud development lifecycle. So before we talk about what we're doing now, let's talk about what we've done in the past. Over the past decade, the way we built and deployed applications has drastically changed. Development has evolved from isolated linear processes into fast and iterative life cycles that leverage cloud and AI to scale. And let's explore how this shift has fundamentally changed the development lifecycle. Traditionally, development followed a waterfall model, a rigid sequential process where work moved step by step through requirements, development, testing, and deployment. Each stage depended entirely on the previous one, and it made development predictable, but very slow, with long cycles that couldn't keep pace with modern developments. Today, most organizations have adopted a more agile or DevOps approach. These methodologies, as we know, have focused on continuous development and collaboration across teams, enabling faster releases and iterative improvements. Instead of working in silos, developers, testers, and operations teams now work in parallel with automated feedback loops that improve speed and efficiency. The evolution in methodology transformed the development lifecycle itself, and the process now flows through a few key phases. Code, where applications are built. Pipeline, where applications are tested, integrated, and prepared for deployment. Cloud, where applications and infrastructure are deployed at scale. And runtime, where applications operate and interact with real-world users. Each of these phases are interconnected and very iterative, and rather than sequential, the heart of this transformation relies on one unifying factor, and that's code. There we go. Code has shifted from being an isolated tool to the unifying control plane for the entire cloud environment. At the application layer, code defines frameworks, libraries, and OS packages that enable applications to run consistently across environments. At the data layer, code governs IAM and permissions, managing who has access to what data, ensuring both security and compliance. At the networking layer, networking policies are also defined through code, automating connectivity and security across services. And finally, compute, where VMs, containers, and serverless functions are provisioned, scaled, and managed dynamically using code. So code governs our applications, the data layer, networking, and compute dynamically and at scale. This interconnectedness has revolutionized how we manage cloud environments, providing flexibility and speed. The challenge that security responsibilities are distributed across multiple teams. And each are with their own tools, their own processes, and their own focus areas. But no unifying element really remains to connect them. The lack of alignment creates gaps and inefficiencies throughout the whole lifecycle. Starting with code, AppSec governs this domain. They're living in their own code scanners, identifying vulnerabilities in code, and ensuring secure application design. However, they operate independently from other security teams and often have limited context about how the risks that they're identifying actually impact production. In the pipeline, DevSecOps typically governs this domain. They're integrating security within the CI/CD pipelines, addressing issues like misconfigurations or policy violations during automation, but their role often stops at deployment, with little interaction with runtime or cloud security. In cloud, CloudSec is governing this. So they're utilizing their tools, their cloud scanners, to understand and monitor the security across the cloud environments that an organization may have. And they focus on the compliance, the misconfigurations, potentially vulnerabilities, but lack visibility into the earlier phases of the life cycle. And finally, we have runtime, where SOC and cyber defense teams live. And they're looking at real-time threat detection and response, addressing risks that have already materialized. They frequently work reactively without insights from AppSec or DevSecOps or CloudSec that could help them address true root causes. Which oftentimes ends up creating a lot of noise and friction for developers. Dev and DevOps teams are at the center of these processes, but they're inundated with findings from multiple security teams, and these findings create a lack of clear prioritization, clear messaging, or context about where remediation should truly occur. So when we don't have prioritizations of risks, developers are receiving alerts from AppSec, from DevSecOps, from CloudSec, but they don't come with clear guidance on what exactly should be remediated first, what's actually most important to remediate within your cloud environment. And developers oftentimes have to figure it out on their own, or maybe never at all. Without unified messaging, teams communicate within their own tools, within their own languages, within their own processes, without coordination. And developers often face conflicting or redundant messaging, making it hard for them to understand what needs to be fixed, when, and why. And last, we have a lack of context for actual remediation. When an issue is flagged, developers rarely have the full picture. For example, a runtime issue might lack the traceability to identify its origin in code, while a pipeline misconfiguration may not indicate how it impacts production. This lack of context slows down remediation and increases frustration. And not just that, but a lack of prioritization, unified messaging, and context isn't just affecting developers. It also creates opportunities for attackers to exploit. Siloed security slows down response times, creates blind spots, and leaves organizations vulnerable. Attackers thrive in these gaps between disconnected tools and teams. So this is what we've just talked about. A vertical security model where each team deploys within their own stack and sees the results within their own tools, lacking context or data sharing with other teams. And to address these gaps, the solution that I'm proposing is that we move to a more horizontal security model, a model that unifies tools, insights, and workflows across all teams. Horizontal security creates a unified layer of shared context between developers, DevOps, cloud security teams, and the SOC. And the shared context ensures that risks identified by any team, whether in code, in the CI/CD pipeline, within the CSPM, or within runtime, are visible and actionable throughout the entire lifecycle. In this model, tools like secret scanners, malware scanners, vulnerability scanners, and data scanners are all interconnected and don't work in isolation. They feed into a shared cloud and runtime context, ensuring that each team operates with the same actionable insights tailored to their specific roles. This eliminates silos, reduces noise, and enables teams to prioritize and remediate risks effectively. In the next few slides, we'll kind of dive into the people and the process and the technology elements required to make horizontal security a reality. All right, so here's the tool. A tool selection is super important to making horizontal security a reality. The goal is to consolidate what used to be separate, disparate tools, individual scanners, into a single platform that provides comprehensive visibility and feedback all in one place. This approach allows you to get rich context about your environment and your risk posture across the entire life cycle. So traditionally, you've had separate CSPM tools, vulnerability management tools, CIEM tools, and they've all lived with different teams, right? So CSPM with cloud security, vulnerability management with a vulnerability management team, and CIEM with an identity team. But now it's all consolidated, and this consolidated view allows you and your organization to prioritize all of these disparate risks effectively. So you're not just seeing isolated risks, but how they impact the entire environment as a whole. By bringing all of this into one platform, developers, DevOps, CloudSec, and the SOC can work together seamlessly, and everyone operates with the same information, tailored to their responsibilities, and ensures faster remediation. While technology forms the backbone of this horizontal security model, it's the people and the process that truly bring it to life and enable this transformation. And let's talk about the tool, the teams and the roles that are needed in order to evolve into this unified approach. In this, I'm proposing a new cloud operating model, but you'll see it's quite similar to what your organizations may be using today. At the top, you have the CISO, who sets the strategic direction, allocating budgets, driving consolidation, and approving the overall cloud security and organizational strategy. Supporting the CISO is the cloud security champion, a role dedicated to defining the cloud security strategy, overseeing tool implementation, and eliminating critical risks and tracking team success. Below that, you'll see all of your traditional security teams, your vulnerability management, your data security, cloud identity and access. And these are all domain-specific teams or risk-specific experts. These are teams that are focused on those specific areas, and they embed the tools that are relevant to them into their teams, develop processes, measure KPIs, and ensure effective adoption for security practices. But again, the tools that they're implementing should be one consolidated tool. On the other side of this chart, we have the business units and those security champions. They're managing security at a local level in each individual team or each individual business unit. They're working directly with those teams to ensure that security is implemented and adopted across within their workflows. Practitioners and engineering teams like DevOps, and other SREs who incorporate security into their daily workflows. They're using the tools that security is providing, managing incidents, and ultimately maintaining security without disrupting their operational practices. All in all, really what I want you to take away from this slide is that in this model, we're decentralizing execution by empowering teams to do the work while maintaining centralized visibility and oversight. It's a collaborative approach that ensures security is embedded throughout the organization without creating specific bottlenecks. And finally, let's talk about the processes that support this. In the center, we have your tool. So your tool is bringing in all of those things that we've talked about already. They're bringing in all of the cloud API scans, your vulnerability scans, your data scans, your registry scans, as well as what you're scanning pre-deployment. So in your pipeline, within your code repositories, and also everything that the SOC needs as well. So logs from your cloud provider, your data, network, and identity logs, and any sort of third-party data that you're trying to feed into it. Because all of this data is fed into one tool, it's very easy for us to be able to prioritize and contextualize all of that data. So let's look at the process as a whole after we have all of this data contextualized. Starting from secure cloud development, you're using the same scanners, the same policy frameworks across the whole SDLC. So the same policies that you have within your pipeline, within your code repositories, are probably also similar policies that you're going to have in your runtime managing security posture. Once code is deployed, you're probably going to look at it in runtime to see a complete visibility of what's been deployed, to understand the risks that are prioritized in runtime, and help you understand what needs to be done next. So ideally, then, you're kind of taking that to your dev teams through specific automations that you may have set up. So each of these dev teams are going to get very specific information that's aligned to them with the centralized oversight and the centralized policy that you've already determined. At the bottom, you have your cyber defense team, who's responding to threats. They're looking at other specific response flows for those. They're investigating based on the consolidated and contextualized data that they've already had. And the best part of all of this is that it makes it super easy for the cyber defense team and the dev teams to understand where they need to remediate, ideally back in the code, because again, it's all contextualized. So let's talk about value. Let's summarize the approach and the benefits that this approach gives for all of these teams and the organization as a whole. Your CloudSec team gets immediate visibility and increased efficiency, and enables CloudSec to manage risks across the entire organization allows the cloud security team to manage risks more effectively while focusing on strategic initiatives like cloud adoption and innovation. Developers can build securely from the start with clear prioritization for risk-aware remediation. This reduces friction, accelerates development cycles, and gives developers time to actually build what they need to build and innovate. AppSec teams benefit from a faster path to remediation, secure by design practices, and simplified workflows that integrate seamlessly into their cloud security stack, improving speed and efficiency. And SecOps teams gain from contextualized threats, fewer false positives, and reducing time spent on investigations and enabling faster, more effective responses, lowering mean time to respond. From an organizational level, horizontal security delivers transformation value to the organization as well. You have unified messaging that we spoke about, so teams operate with shared context, ensuring that they speak the same language, which reduces confusion and fosters seamless collaboration. With the unified security model, where you're kind of centralizing all of these policies and workflows into a single model, organizations achieve efficiency, consistency, and a stronger security posture. From a tool consolidation perspective, you see reduced complexity, lower costs, and streamlined management across the security ecosystem. And you have better agility and a better security posture, where risks are prioritized, identified, and resolved in the tool and across teams, ensuring comprehensive coverage and resilience against threats. And last slide here is a cloud security maturity framework, which outlines the key steps and stages that organizations must progress through to achieve a unified, stable, and effective security model. This is not just a one-time goal, but something that's iterative and improves as your organization is improving, aligning with security and business objectives. It all starts with gaining visibility. You start with limited or fragmented visibility, but the goal is to, with your tool, to achieve complete multi-cloud visibility across all accounts, resources, and at every stage of your life cycle, from your pre-deployment to runtime. Once you have visibility, your goal is to reduce risk. So this starts with individual clouds and architectures, progressing to comprehensive risk reduction across all of your cloud environments. Then you're democratizing. You're bringing in your dev teams and your DevSecOps teams to actually self-service and remediate issues within this one tool that has prioritized and contextualized data to remediate and actually maintain compliance. Finally, we're looking at shifting left, so hardening pipelines, reducing drift, implementing consistent policies across pre-deployment and post-deployment, and ensuring secure by design practices from the ground up. Finally, last step, but ideally happening all together, responding to threats with automated SOC workflows and robust incident response frameworks. At this stage, you're not just reacting, you're proactively managing security at scale. And that is it. Thank you so much.